A very warm welcome to you to this chess lecture. My name is Mike Schäfer. I'm the director of chess of the Center for Higher Education and Science Studies here at the university. And tonight we have the pleasure of saying welcome also to Massimiano Bucchi, who will give the lecture today on visual science literacy. And it's a bit, I can't do this for every lecture that we have, but for this one I can do it with a personal anecdote, because back when I was starting my scientific career in the early 60s, no, it was 98 or something, my interest in science communication was already peaked, and one of the first books I actually read was one of Massimiano Bucchi's books, Science and the Media, Alternative Routes in Scientific Communication. And that is actually one of the very few books, and I won't show that to you, where I still have a 5-page extract, because at the time I thought, well, that's how you do it. That's how you do science. You have to have extracts, and you can pull them out of the shelf later on. And I still have that, and I still quote that occasionally. And for example, Massimiano has this metaphor of science du chef, a science communication or a science media coverage that adheres to the logics of science. Science determines what's important. Science determines how science is portrayed, etc., etc. So it's science du chef, and that's something I quote very often from this book. So there's an early influence there, and I'm happy that you're here today. But not only for this reason. We're also happy to have Massimiano here because he's one of the leading experts of science communication, of the public perception of science in Europe, probably. Massimiano came here from the University of Trento, northern Italy, where he has a professorship in the STS program, Science and Technology Studies program. Massimiano studied sociology in Trento and then did his doctorate at the European University Institute in Florence, and went back to Trento in 2005 and has been a professor there ever since, with a lot of visiting appointments in very reputable universities like Berkeley and others. And what he does research on is science communication on the one hand, public perceptions of science on the other hand, the attitudes of citizens towards science and technology, and if you like, the historical and social changes in the relationship between science and society and the different angles that this has. He's published very widely a lot of books. One you see here, one I already mentioned. There's a very readable, even though few people probably read it from front to cover, a very readable handbook that Massimiano has edited on the Routledge handbook on science and technology communication. So that's a reference work that a lot of us use in the field. He's published in journals like Nature and Science and Public Understanding of Science, and for a year now approximately he's also the editor of Public Understanding of Science, one of the leading journals in the field. And today Massimiano is tackling an issue that on the one hand is probably one of the most important and to some extent oldest issues in the field of perceptions of science by the public, which is science literacy. What do they know? What do they think about science? But Massimiano does that with a different angle, highlighting a facet that hasn't really been analyzed so far, namely visual perceptions. What do people know about the visuality and the visual representations of science? We look forward to that, Massimiano. Thanks for coming, and the floor is yours.
Thank you.
Oh, I have one. Sorry.
Yeah,
sure. One more thing to say. We're doing a podcast today of Massimiano's lecture. So if you don't want the back of your heads on camera, this is your chance to move to one of the 3 back rows, because there you won't be in the picture. But you all look like beautiful people, and you probably don't need to move anyway. So, Massimiano, sorry.
No, thank you. Thanks for this very nice introduction and for inviting me. Let's see if I can. Yeah. Okay. Today, as Mike has mentioned, I will speak about visual science literacy. And in a minute, I will try to clarify what we mean by this. I will draw upon an empirical study that we published in this journal, Science Communication, and on a more historical study that I did with a colleague historian of biology, about the role of images in science communication. So what are we talking about? Images in science communication, as Mike already was mentioning, we're talking about something which is quite old, which has been there since the beginning of modern science. Nowadays, we might have the impression with our contemporary eyes that this is a photograph taken at the microscope. It's actually a very accurate drawing that Robert Hooke was the curator of experiments at the Royal Society. And one day, this is an interesting communication story, the king, Charles II, was going to visit the Royal Society. And this whole thing of science which was not called science at the time, because science is an early 19th century word, scientist. How could they explain to the king what they were doing, this strange observation at the microscope? So Robert Hooke was commissioned a book, because of course they couldn't ask the king to sit and look in the microscope. A book of exquisite drawings, as they said, for the king. And this is what he did. It's a book only of illustration, mostly taken at the microscope. But then, interestingly, when the issue came of publishing this book, the Royal Society fellows became a little bit worried that this was too beautiful, it was too appealing. This was a bestseller. So Robert Hooke published anyway this Micrographia, and the Royal Society took a little distance. But this was a bestseller, something that Samuel Pepys, famous writer and politician, said, this is the most ingenious book I've ever seen. So the intellectuals, the people who were reading books at the time, everybody wanted to have this book. So the images have been at the center of science communication since the very beginning. But if we come to our present, what we do, like the colleagues here in Zurich are doing, we try to understand how people understand science communication. So, for example, in social media, a lot of the exchanges and the circulation is made through images. There are specialist studies in digital communication that can tell you how much more often people are posting or circulating posts if there is a picture on them. And this holds for science communication as well. So when we look at science literacy, traditionally, this is what we do. We ask questions to people. We try to ask questions that everybody who knows about science would be able to answer. So this is how we do it in Italy, which is the way the Eurobarometer has been doing it, or in the US, for example, they've been doing it. There's a question about electrons. There's a question about antibiotics killing viruses and bacteria, or whether the sun is a planet or not. And what the numbers, the figures that you see is the number of people, the percentage of people in our sample, which is a representative sample of Italian population, who get the correct answers. And this is increasing. I mean, of course, you can still say, if you want to be pessimistic, that 40% of Italians still think that the sun is a planet. So, of course, we can always discuss, and that could be another talk. We could discuss why it is slowly increasing. Part of the explanation we give is that because the younger generations are more educated. And the ability to answer this question is very much a function of the general education level to some extent. But this doesn't tell us anything about what use people make of these images about science that circulate, for example, in digital media, or what people see on the internet. So the question we had with my colleagues was, can we devise something similar to this to assess the competence and the understanding, so to say, or the visual literacy. So how people make sense of images about science. And then, of course, the first problem we had was to choose these images. So if these are standard items, and of course, again, we could discuss whether these actually measure scientific literacy. But of course, the idea is to have a basic indicator that you can repeat over time. What are the classics? What are the images of science that everybody with a general education should know? And that, of course, could be a long debate, but this is what we tried. We tried this in the last 3 editions of our study, which is a yearly study. Of course, we had to, but we were very cautious indeed in that because we did it gradually. We had to change a little bit our system of survey, introducing a web survey, because you cannot ask about images over the telephone. That's obvious. So these are the 3 years ago, 2014, we started with these 3 examples. And you can make your own test and see what you have answered. And this is how Italian citizens responded. Almost everybody recognized this as a DNA structure, the classical double helix. I'll get back to this image, which is a very interesting one. A little bit less, but still very high, the first nuclear test. This is from Los Alamos test. We also asked, what is your reaction? We were interested also, because images trigger emotions much more than text. And this is another classical image from the Apollo mission, 1968. Some people say this image was very influential on the emerging environmental awareness, showing the fragility of the Earth from the space. So very, very high, the ability to recognize these classical images. The next year, we tried something different. Well, we asked again about the double helix, so we could see whether the responses were consistent, and a little bit less, but still very high. This image of the Bohr scheme of the hydrogen atom from his Nobel lecture is much more difficult for our respondents. And I'm sure you've seen this image on the right. This is another very interesting case. It's an anonymous image that it's used all the times when it comes to IVF, that it is what it is about. It probably comes from a fertility center, but ironically, it's an image about reproduction that doesn't have a mother or a father. We don't know. So, but it's continuously propagated. Last year, we also introduced images of scientists. And not surprising, almost everybody recognizes Albert Einstein. We're in Zurich here, 91%. A bit more interesting that an early picture of Marie Curie, 2/3 of the Italian can recognize. And I don't know if you know this contemporary scientist. She's the director of CERN. It's quite visible in Italy. 76% of our respondents can recognize her. And quite interesting, this figure is much higher if you show the picture than if you ask, who is Fabiola Gianotti? If you ask who is Fabiola Gianotti, about 57% would say yes. But if they see the picture, then they recognize. So what do we make of this? Well, that's another interesting story. A newspaper, a financial newspaper, Sole 24 Ore, asked us to use our images for a test on their website. And in one day, they had about 30,000 people taking this test. So, and this would have never happened with the questionnaire, with the classical questionnaire about. So people, apparently, they also had fun doing this as a kind of a game. And of course, we cannot use the results because they're not representative, but they were quite surprised, and we were also quite surprised. But this is what mostly matters to us. The red line is the visual science literacy indicator, and the blue line is the science literacy in the last 3 years. And if you see, and obviously you see that people do much better with images than they do answering text. And since we included also images of scientists, the percentage of those who give zero answer, or who fail in all answers, drops to 0. The other interesting thing is that there are obviously differences, as I said. The ability to respond to questions, to items of scientific knowledge is very much related to education and age. The ability to respond to questions about the visual is also related to education, a bit less, but is not related to age. So, to conclude this part, of course, you could easily argue that recognizing an image associated with science like DNA double helix or the face of Albert Einstein doesn't mean that you know much about science. Of course, we are aware of that. But for science communication, our result may imply, or actually imply, that there is a sort of that you could use images as a powerful hook for a content or for something more or something that you want to tell more in depth. That they certainly, that being able to connect to a familiar image might be a relevant tool for science communication. Yes? Yes. In the non-visual, the young people do much better than the old. Yes. So that, as I said, it's also a bit more transversal to age groups, visual literacy. That's another feature. But the most important thing for us, the way we see this study, is a methodological exercise. The idea is how we can develop indicators for visual science literacy. Otherwise, we are looking at science literacy only based on text and ability to answer questions, and in the contemporary age and the way science communication works, this might not be enough. So we are hoping that other colleagues will try similar things, and we might develop, for example, comparison with the same images or with different images. So this is the more recent empirical part, but as I promised, I'm going to show you a little bit of examples throughout history that we studied with my colleague. Let me start with the classical one from Italy. These are drawings that Galileo did for his book, Sidereus Nuncius, 1610, of the moon. Galileo was not the first to observe the moon. Other natural philosophers, other astronomers were doing the same observation at the time, but he was the first one to understand that the moon surface is not smooth. How could he understand that? Well, one of the main reasons is that he was trained in the chiaroscuro. Galileo's initial training was in drawing. He went to the academia. And so he knew how to interpret the shades and the light. So he was the first one to come up with this understanding. Also through because you can imagine, they had to do the observation and draw at the same time. They couldn't take a picture. But look at this image. This is just 1 year later. This is in the Basilica di Santa Maria Maggiore in Rome. Ludovico Cardi de Cigoli made this fresco, commissioned by the church, and he was a fellow student with Galileo. They knew each other, and he's drawing the moon, contrary to the Catholic dogma, which used to be a perfect, everything that was in the sky used to be perfect and smooth. He's drawing the moon the same way he had seen it in Galileo's drawings. So we immediately have an influence on art of the Galileo drawing. This is the double helix. This has been called, for example, by Horst Bredekamp, one of the most powerful icons, not just of contemporary science, but probably of contemporary age. But as you know, this is a representation. This doesn't come from a photograph or from an observation at the microscope. This was drawn by an artist, Odile Crick, the wife of Francis Crick, based on this sketch that Francis Crick himself made. This is the picture. This is the picture that was taken by Rosalind Franklin and her group. And this was the picture that gave the idea to Watson and Crick. In his autobiography, Watson said that immediately when he saw this picture, his heart started to beat. This has been called by the BBC, this is called Photo 51, the most important photo ever taken. And this was published not in Watson and Crick article, which is this, it's a very short article, but in another article in the same issue. So this is interesting because it was a metaphorical representation initially, but this has become reality. This is, even our interviewees, when they see this image, they think about DNA. This is how DNA is. And this is a comic sketch that Maurice Wilkins did, just to make fun of it. This is WC stands for Watson and Crick, and there's a corkscrewer like a double helix. And the bottle is about the secrets of life. And you see the influence even in contemporary dance. This is from a ballet in New Zealand. I'm sure you've seen so many of these examples in advertisement, in art. This is what an icon, when a science image becomes an icon. Have you ever seen a dodo? Maybe in cartoons? Dodos are a very interesting animal for science because it's the only animal that was extinct in modern age. The first dodo was seen in 1598 by humans in the Mauritius Islands, colonizers from Portugal and from Holland. And very few dodos were taken to Europe. And some of them were featured in picture, like this beautiful painting by Roland Savary, who probably saw a dodo at the court of Rudolf in the Netherlands. So he made this kind of pictures. The last dodo, we know for sure, was probably seen by humans in 1662. But science got interested in dodo around in the late 19th century. So when Richard Owen in Oxford, he had some remains of the dodo, and he had to assemble. What he did was to draw the shape of the dodo based on these art paintings, because he had never seen one. But then he realized, this is for example, the illustration in Richard Owen book about the dodo. So this is how he imagined, as a scientist, the dodo. But then he realized he had made a mistake, that the dodo, so for example, paleoanthropologists nowadays think the dodo was much thinner, so rather different from the one we got used to. But then the image already was fixated in perception and culture. For example, Lewis Carroll, who was, by the way, a mathematician, who was visiting regularly the museum where the dodo in Oxford, where the dodo was presented. He created a character in his book, Alice in Wonderland, that is called the dodo, probably playing on his name because he couldn't speak very well, so he was saying his real name was Dogson, so he was saying Dodo Dogson. So probably the dodo is himself, and this is how his illustrator is portraying the dodo. So we have an image from art that influenced science, and then this image, which was a wrong image, influenced literature. This is and of course the dodo is extinct, but we know in comics, in cartoon, is much more, continues to be popular, but still with that old image. I'm sure you're familiar with this. This is what we think when we think about Frankenstein, right? This is what Lego thinks when thinks about Frankenstein. But this is not at all present in Mary Shelley's original book, where of course Frankenstein is the scientist, is not the monster. So this image, this visual stereotype was created for a Hollywood movie in 1931. Was a very elaborate makeup. This image is still copyrighted by a Hollywood studio. So if you buy for Carnival or Halloween this mask, part of the money goes to that. So it's another example of how an image traveled and then got its shape and its stereotype and became a sort of an icon. I'm sure you have seen this. This is called the March of Progress. You see it everywhere. Now, where does it come from? If you ask an evolutionary biologist, he will tell you that this is all wrong. This is not a linear. And actually, the image, if you go back to Darwin's original publication, the only image he had was a sketch of a bush. Because evolution runs in parallel. There are still monkeys next to humans, for example. So it's not a linear ladder, a progressive ladder of evolution. But this image, very powerful and very influential, comes from a popular textbook, 1965. Rudolf Zallinger made this image for a textbook with the famous anthropologist at the time. But this image was folded. And it had a lot of explanation. So actually, they didn't mean to make the ladder as the one we are used to. But of course, because it was folded, it was much more simple. And that image stuck on public perception. And this is what we see. And poor Darwin, he thought the opposite. And in the stamp, you still find this. The butterfly effect, something very influential also in popular culture. Edward Lorenz was a mathematician and a meteorologist. He wrote a very specific paper in 1963, which was called Deterministic Non-Periodic Flow in the Journal of Atmospheric Sciences. The idea was that minimal differences in the initial conditions in complex systems like meteorology can produce massive changes in the process at the end. Nobody paid much attention to this paper until in 1962 he was invited, oh no, I don't have the image here. In 1972, he was invited to the AAAS, so to a broader conference of scientists to give a presentation. And he couldn't send his title in time. So his colleague made a completely different title for him. And he had read in the paper, the only example that Lawrence made was that of a seagull flap having effect, for example, on a thunderstorm. So his colleague changed the title and called this, does the flap of a butterfly in Brazil can produce a tornado in Texas? And this made a huge success and huge impact, and this paper became one of the most cited ever. Probably this scientist, this colleague of Lawrence, made this title up because he had read this short story, A Sound of Thunder, by Ray Bradbury. It's a story about time travel, where it's a science fiction story, where a guy goes back in time and kills inadvertently a butterfly, and this triggers a series of effects that change the course of history. So once again, we have a combination of popular culture and science producing. These are the original, two of the original images. This is one of a contemporary image produced by scholars who work on this field of Lorentz. But of course, it became also through James Gleick, bestseller on chaos. And it's also, if you watch Jurassic Park, for example, the mathematician would make a reference to the butterfly effect. If I ask you, what does an atom look like? What is your answer? Yes. That's it, right? Now, this picture was never published by any physicist in any text. Ernst Rutherford described the atom without this picture. He proposed this model of a Saturnian atom, so as a metaphor compared to Saturn as a planet and his rings. And he was drawing this metaphor from another scientist, a Japanese scientist called Nagaoka, which was drawing this from another scientist, Perrin, which was comparing the atom to a solar system. So this metaphor. When Niels Bohr had to actually draw the atom, as we saw before, this is the hydrogen atom, was quite different from that one. But this one is the one who stayed in public perception. This is Nagaoka, that's a stamp from Japan with Saturn, but again with this simplified and stylized atomic system. This is a stamp about Rutherford, where he himself is part of the atom. This is the Atomic Energy Commission in the US. They is still using this symbol, even if, as I said, doesn't have any meaning for the specialist. And this is a comic, Watchmen. So this superhero who is also a scientist, they give him a helmet with the usual shape of the atom, and he says, it doesn't make sense, I'm going to make myself. And he draws himself the hydrogen atom. So that's it. That's the reference to our study, and that's the book that we published. I'll be happy to further discuss with you, both on the empirical part and on the, I mean, this is also empirical, but it's more historical series of examples. Thank you.